Hello friends, welcome to the Basics of Geography series. And this is here, I welcome you, and I am Rohit Mandan and I am your mentor in this Basics of Geography series. Now in this series we are going to start sedimentary rock. What are sedimentary rocks? Before we start what are sedimentary rock, we have to understand the importance of the sedimentary rock. An introduction to the sedimentary rocks. And why sedimentary rocks are important? It is seems that because in the UPSC 2022 one question was asked, describe the characteristics and the types of the primary rocks. Primary rock means igneous rocks. But in the next UPSC exam, like in 2023, there is a probable chances that the questions can be asked on the sedimentary rocks because they hold a significant importance into our human survival. Now explain the importance of the sedimentary rocks. So let's discuss the importance of the sedimentary rocks. Why sedimentary rocks are important? Because if you look at the composition or constituent of the sedimentary rocks, most of the solid earth consists of the igneous and the metamorphic rock that constitute about 95%. That means remaining 5% are the sedimentary rock. Then why sedimentary rocks are so important to us? Okay, let's discuss. The importance of the sedimentary rock. The importance of the sedimentary rock can be discussed under a clues to the geological past, economic importance we will see, and the ecological importance. And through these 3 points, we can discuss the importance of the sedimentary rocks. Now, how sedimentary rock? The first important, how sedimentary rocks provide evidence to the geological past. Okay, so let's look at how these sedimentary rocks provide importance to the geological past. Why? Because sedimentary rocks act as an interface. Interface among the geosphere, hydrosphere, biosphere, and atmosphere. So because of it acts as an interface, that means it has a footprint of all these. Whenever there is a change in the geosphere, hydrosphere, atmosphere, and biosphere, all these footprint will be available on this interface. That means it's sedimentary rocks. So can we say that these sedimentary rocks are the primary tellers? Okay, primary storytellers. So can we say that these are the primary storyteller of the past climates, life forms, and evolution of the lives, how life is evolved over the time periods. So can we refer from this? So yes, we can refer, and that's why we call the sedimentary rocks as a primary storytellers. So what, how provide, because जो sedimentary rocks होते हैं, they provide insight into the past climates, ecosystems, and ocean environment. Because we know that the sedimentary rocks has varieties like detrital sedimentary rocks, organic sedimentary rocks, and the chemical sedimentary rocks. So from this we can also refer the textures of the sedimentary rocks. Okay, if we refer the textures, so what texture tell us? Texture tells us the grain size. And what grain size tells us? Grain size will tell us the time that जो depositions currents है उसके बारे में बताएगा. Okay, the times they will tell about the time, deposition current. Okay, distance travel by these grains. Okay, and the structures. The structures of the sedimentary rocks also tells about this sedimentary environment, like it is continental environment, whether it is marine environment, whether it is transitional, means shoreline environments. So through this we can also refer how sedimentary rocks are the primary storytellers. That means it clues to the geological past. So this is how sedimentary rocks provide geological clues to the geological past, because we know that the sedimentary rocks forms in a layer structure, in a strata. So because of this strata, if you look at this, because of this strata, this particular strata signifies that a particular episode of deposition. This is a particular episode of deposition. Here this particular episode of deposition, and this here another particular episodes of deposition begins. So because they form under different environment, so these vertical configurations of sedimentary rocks, they provide clues to the geological past. So sedimentary rocks record changes because they contain fossils and other clues about the geological past. Vertical changes in the rock type represent the environmental change through the times. So here, this is how sedimentary rocks hold importance and clues to the geological past. Now, economic significance. What are the economic significance? What energy resources we use today? Coal, crude oil, natural gas, shale, uranium, groundwater, major resources of the iron, aluminium, magnesium, okay, potassium, phosphate, fertilizer. These all are the result of the sedimentary rocks. Okay, the coal is also a sedimentary rocks. Okay, crude oil is the crude oil, or for natural gas, sedimentary rocks act as a natural reservoir. These act as a natural reservoir. I will tell you, okay, how sedimentary rocks act as a natural reservoir. Shale, shale is in a sedimentary rocks. Okay, when this oil penetrate in this sedimentary rock, it is act as a shale oil. It is also a significant energy resources, non-conventional energy resources, uranium. Okay, because nuclear power is going to be very dominant in the upcoming times. Okay, so uranium is going to play major roles. Groundwater reservoir. Okay, major sources of the iron, aluminum. So if you look at this economic significance, we cannot ignore the sedimentary rocks. Now we have seen the importance of the economic importance, ecological importance, or the clues to the geological past of the sedimentary rock. Now we will see the origins. How sedimentary rocks origin? कैसे वो originate हुए? Okay, what does sedimentary mean? So first we will tell what does sedimentary means. Sedimentary means sedimentum. So it is derived from the Latin word sedimentum. Sedimentum means, what does sedimentum means? To settle down from the fluid, and these fluids can be a erosional transporting agents, and this can be water or air or wave or glaciers. So this can be anything. Okay, depositions of solid particles occurs when wind, water, okay, or other जो transporting agents है, when they slow down. Okay, when they slow down means their carrying capacity, okay, decline significantly as a glacial ice melts. Okay, so depositions starting. Okay, now this is a diagram here which shows that how the depositions, how erosions took place. Okay, so here you can see that first deposition, first weathering will took place. Then after weathering there will be a mass movement here. Mass movement is the result of gravity. So because of the mass movement, then it comes in the contact with the glaciers. Then through the glaciers, these gravels or different types of these particle size, it transports through streams, rivers, okay, and through winds. So they form different type of the depositional landforms like dunes, like delta, okay, and through all these erosion agents, what they are going to do? They are going to deposition of the different types of the sediment. Now process of sedimentary rock formation. What are the process of the sedimentary rock formation? There are three processes sedimentary rock formations के. So first is weathering, the second one is erosion, and third one is deposition. So without weathering, erosion will not take place. Without erosion, deposition will not take place. So for process of the sedimentary rock formations, all three factors, all three process will take a important position. Now, example of the depositions. Okay, look at the example, like the mud on the floor of the lake. Mud on the floor of the lake is also an example of the deposition. Delta at the mouth of the river is also an example of the depositions. Gravel bar in a stream bed is also an example of the depositions. Like the particles in the desert that forms sand dunes is also an example of the sand dunes. And the most important example that everybody knows is even household dust are the examples. of the deposition. So these are the example of the deposition, and depositions, through depositions there is a compaction and cementation, and through this sedimentary rock form. So deposition is an integral part of the sedimentary rock formation. Why sedimentary rocks are of three types? Why sedimentary rocks are there? Because of the environmental conditions. Okay, because of the different environmental conditions, transportations, depositions, and transform into the solid rock. So because of the variety of ways that the products of the weathering products are transported, deposited, and transformed. That's why sedimentary rocks are of the three types. So then what are these three types of the sedimentary rock? Let's look. So these are the three types of the sedimentary rock. The first is detrital sedimentary rocks, chemical sedimentary rocks, and organic sedimentary rocks. Okay, what is detrital sedimentary rocks? Detrital sedimentary rocks means, so first if you look at the dictionary definition of the detritus, detritus means hota hai particle size. Particle size grains derived from the primary rock. So when these particle sized grains have been transported and deposited, this type of rock form we name them detrital sedimentary rocks. So these are solid particles. Okay, but what is chemical sedimentary rock? When sedimentary rocks form through the chemical reactions like evaporites, okay, like precipitations, okay, through this, like the salt dome. If you look at the salt dome, these are the example of the chemical sedimentary rocks. Organic sedimentary rocks like coral reefs. Coral reef is the example of the organic sedimentary rock. So we will look at one by one. The first we will look at the detrital sedimentary rock. What is detrital sedimentary rock? तो सबसे पहले देखते हैं what is detrital sedimentary rock. So discuss the primary basis for distinguishing among the detrital rocks and describe how the origin and history of such rock might be determined. How we can determine. Okay. Now look at what are detrital sedimentary rocks. Detrital sedimentary rocks क्या होती है? When accumulation of the materials that originate and transported as solid particles derived from both mechanical chemical weathering. So when accumulation and depositions of the originating and transporting solid particles derived from the both mechanical and chemical weathering took place, they form detrital sedimentary rocks. Okay, so what are detrital sedimentary rocks? So detrital sedimentary rocks formed by the depositions of the solid particles. Deposition of the solid particles. Now, what are the chief constituent of the detrital sedimentary rock? So, chief constituent means detrital sedimentary rocks are formed by the solid particles. So, what type of solid particles can be in formations of the detrital sedimentary rocks? These can be clay minerals. So, clay minerals and quartz. Clay minerals and quartz are the primary or the chief constituent of the most sedimentary rocks. In a part, other common minerals such as detrital rocks are the feldspar and micas. So these are the chief constituent of the detrital sedimentary rocks. Now, what is the basis of division among the detrital sedimentary rocks? How we can divide the detrital sedimentary rocks? So these are divided based on the particle size. Okay, so based on the particle size, we can classify the detrital sedimentary rock, and we can understand these detrital sedimentary rock through our chart. So this is in a chart. Here you will look at this column will tell you the size range. Okay, these are the size range of the particles, and this size range from 256 to 1 by 256. Okay, and this is in a particle name according to their particle size, and this is a common name given to the particles, and this is here in this column. We will look at the detrital sedimentary rock. So if the particle size has a greater than 256 millimeter, we call them boulders. If it is 64 to 256, we call them cobbles. Then niche, if you look at the bottom, pebbles, then granules. So the common name of these particles name like boulder, cobble, pebble, we name them gravels. So these are the gravel size particles. Then 1 by 16 to 2 millimeters, we call them sand. ठीक है, sand size particles, and नीचे in the bottom silt and clay size particles. So according to the particle size, they form different type of the detrital sedimentary rock. Like the gravel size particles form the conglomerate and breccia. Okay, sand size particle form the sandstones, and silt size particle form the siltstone, and clay size particle form the shale. Okay, and this is going to very important for us in future. Shale. We will look at the shale in detail. Now, why particle size is the base of the detrital sedimentary rocks? Because of the current की जो power है carrying capacity, because of that. So if you look at the current carrying capacity, the current of the water or air sort the particle size. So sorting the particles, what is sorting then? sorting का मतलब कुछ नहीं होता है, sorting means छटनी करना किसी चीज की, ठीक है? तो sorting, तो they can be sort according to the weight, okay, according to weight or particle size. So the stronger the currents, the larger the particle size that can be carried. So it is completely and absolutely depend upon the current power. Now we will look at the shale. Now we will look at the what is shale and why shale is so much important to us. What is shale? Because we already know that the detrital sedimentary rocks are divided based on the particle size. So shale is a sedimentary rock consisting of the silt to clay size particles. Okay, so these contain silt to clay size particles, and because of this particle size we call them shale. So these fine grained detrital rocks account for the well over the half of the sedimentary rock. If you look at the sedimentary rock, there are 5% sedimentary rocks only. In these 5%, 50% are shale. Okay, now how does shale forms? The tiny grains in shale, indicate that depositions occurs as a result of the gradual settling of from the relatively quiet non-turbulent currents, because shales are very fine grains, okay, clay size particles. So if there is a clay size particle, there is a very obstructions to the depositions, because deposition, what is deposition? Deposition is settling of the these clay size particles. So this cannot be occurs if there is some obstructions, because it will occurs in the very quiet and non-turbulent currents. And such environment includes what this environment will be. These would be lakes, river floodplains, not river. That would not be river, because rivers have na turbulent currents. Okay, lagoons and the portions of the deep ocean basins. Okay, so these are the continental shelf bhi nahi hoga, because continental shelf has various deltas or other types of the features hai, so there is a turbulent features of this continental shelf. That's why deep ocean basins are the on a fertile ground for the formation of the shale. Okay, now what information chemical compositions of the rock provides? तो chemical composition जो rock का होता है, what they provide to us? One example is black shale. If there is a black shale, that we can, what can we infer from the black shale? We can infer from the black shale that there is an organic content, organic matter. If there is an organic matter, that means shale are formed under such conditions that there is a oxygen depleted regions, like okay, so there is an oxygen poor environment. Because of oxygen poor environment, these organic materials do not readily oxidize. So this is how from the chemical compositions we can inform many informations in sedimentary rocks. So this is an example of this shale. This is an example of the black shale. If you look at the black shale, you will find these are the remains of the organic content. And here we can also refer that in which type of the rock you will find the remains of the fossils or organic matters. This is the sedimentary rock, and especially in sedimentary rock, this is an example of the shale. Now look at the why geologists describe shale-weak sedimentary rock, because of their formations, their process of the formations. We know that these clay-sized particles, if these clay-sized particles accumulate over the time periods and through the compactions, through the compaction. The pore space between these clay size particle is so little that it prohibit the entry of the any solutions. What solutions? Cementing solutions. So that's why cementation जो होता है यहाँ पे वो नहीं हो पाता cementation, and that's why these sedimentary rocks are very weak. Okay, so as silt and clay accumulates, they tend to form a layers. Initially, the particles in the lamina are oriented randomly, but what gradually what happens? High percentage of the open space called the porous space. But however, this situation usually change over time as additional layer of sediment pile ups and compact the sediment below. Now, how this happens? Because of the compactions, and due to the compaction, these open porous space जो fill है, they become tightly packed. They become tightly packed, and because of the tightly packed nature of these clay sized particles, they prohibit the entry of the any cementing agents, and because of that, cementation does not take place in the cells, and that's why geologists refer them weak cell. Now, then what makes them still weak? Because of the cementing, lack of the cementing agents. So this is an example of the cell. If you look at the cell basically क्या करते हैं? Cell signifies that कि these are the very weak होते हैं, and they are मतलब ये क्या होते हैं? अपने plane से divide होती है. They divided according to their plane. So this is an example of the cell. Now, why cells are the primary reservoir of the groundwater, petroleum, oil, etc.? Why? It is because of the permeability. Okay, because the inability of the water to penetrate, because if any solution is there on this upon the above the cell, okay, so it prohibits the penetration, and that's why it acts as a primary reservoir for the groundwater, because the inability of the water to penetrate cell microscopic porous space, because you know that these are the clay sized particles and these not have any porous space. If there is no porous space, because these are the very microscopic, and that's why water cannot penetrate through the cells, and that's why it acts as a primary reservoir for the groundwater and the petroleum oil. Now, shale, mudstone, and siltstone, how we can differentiate? The difference between the shale and mudstone is the fissility. What is fissility? Fissility is the breakable, that which can be chapped, clapped, or split. Because shale can be clapped or split along the planes. The shale must exhibit the ability of the split into a thin layers along a well-developed plane, closely spaced plane होता है. But if you look at the mudstone, it does not break into along the plane. Then what is mudstone? If the rock break into chunks or blocks, we call them mudstone. Okay, siltstone, as it is the name implies, silt is the composed largely of the silt-sized particles. So if silt-sized particles form such sedimentary rock, we call them siltstone. So this is an example of the shale and mudstone and siltstone. So here you can see that the shale can be split or clapped into along a planes, but mudstone and siltstone can't be. Why shale does not usually attract as much noticeable less abundant members of this group? Because this is less resistant to weathering. Okay, because of the high weathering, खेलते क्या होता है कि they break into the small chunks, and that's why these are not so noticeable. Here you can see that because the bed of the resistant sandstone and limestone produce the bold cliffs. These are the this is an example of the Grand Canyon of the USA, and this is the prominent outcrop. These are the outcrop, but shale does not produce such outcrop because shale is weak and poorly cemented. So because of the weak and poorly cemented, these are more vulnerable to the weathering, and that's why weather into debris, and that's why these are not so noticeable. But that doesn't mean these are not important to us. Now, sandstone. What is sandstone? What is sandstone? Sandstone is the name given to rock in which sand-sized grain particles are there, because as the name implies, So there is a sand size particles. Okay, so after shale, sandstone is the next. Okay, because we know that the shale constitute about 50%, and then this sandstone, they constitute about 20% of the total sedimentary rocks. Okay, this is an example of the diagram of the sandstone. And why particle size vary in the sandstone rocks? Because of the sorting. Then what is sorting? If you look at this sorting, these are the very poorly sorted rocks. This is very poorly sorted rocks. This is poorly sorted rocks, and well sorted and very well sorted. What sorting tell us? Sorting tell us about the deposition of the depositing जो current होते हैं उसके बारे में बताती है. Okay. So if you look at these sediments are very poorly sorted. Okay. So these are the very poorly sorted. That means deposition जो current है has a very high power. Okay, this carrying capacity is very high. But if you look at the very well sorted, तो deposition जो current की जो power होंगी, carrying capacity होगी, is not so much significant. Okay, that's why like wind. If you look at the wind, wind does not have so much significant carrying capacity. That means it has it can transport only fine particles. So it has a high sorting power. This has a high sorting power. But glaciers have a very high carrying capacity. That means it does not have so much sorting capacity. So this is an example of the sorting. This is poorly sorted. That means we can infer from this like what type of depositing current will be there, that their time, their distance, all we can refer from this sorting. Now, what actually degrees of sorting tell us? The degree of sorting tell us about the, what can learn much about the depositing currents. What type of depositing current would be there, like the winds or streams, your wave or glacier. Okay, deposit of the wind blown sands are usually better sorted than the deposit sorted by the wave activity. Particle goes by wave are commonly better sorted than the materials deposited by the streams. So here we can see that the first wind has a high sorting power, then wave. Okay, then streams, then glacier. Okay. Now, sediment accumulation that exhibit poor sorting usually result when particles are transported for only a relatively short time. So, first, what sorting tell us? First, sorting tell us about the depositing current. Then it also tells about the distance. What distance particle size travel? So relatively short time. अगर poorly sorted है, तो relatively short time it travel. Okay. Then rapidly deposited. For example, when turbulent stream reaches the gentler slope at the base of the steep mountains, its velocity quickly reduces and poorly sorted sands and gravels are deposited. So this is how we can refer from the distance and also time. So how the shape of the sand grains can also help decipher the history of the sandstone. So from the जो shape है, जो sand size जो particles है, from which we can refer from here the time, distance, and the transporting agents. So here in this diagram, we will look at the angularity and sphericity. Okay, so this is how angularity will increase. So here particle size has a low angularity, but here roundedness increase. So what it tells us? It tells us about the time and distance. What time and distance it travel? What time and distance it travels? Okay. तो here this has a very low sphericity, but जब ये time और distance travel करेगा कोई रो, then it is going to be very high sphericity. Okay. So this is how we can see what we can refer from the angularity and sphericity. So how transport affect the mineral composition? We know that transport also can affect the mineral composition, like substantial weathering. Okay. like substantial weathering and long transport. Substantial weathering and long transport lead to gradual destructions, of the weaker and less stable minerals. Okay, including the feldspar. अगर if you look at the feldspar or ferromagnesian जो minerals है, they are more vulnerable. Okay, they are more vulnerable to the weathering and the gradual destruction. But अगर if you look at the quartz, it is highly resistant, and that's why it is very durable, and it is usually mineral that survive a long trip of turbulent environment. So from that we can also refer that the transport can affect the mineral composition. Conglomerate and breccia. So what is the difference between the conglomerate and breccia? So if you look at the conglomerate consists largely of the rounded gravel size particles. But if you look at the breccia, you will find that the spherical particles होंगे वहाँ पे वो मिलेंगे आपको. So these are very poorly sorted because the openings between the large gravel particles contain sand and mud. Okay, so these are very poorly sorted. Gravel accumulates in a variety of environments and usually indicate the existence of the steep slopes or very turbulent currents. The coarse particles in conglomerate may reflect the actions of the energetic mountain streams. Why? Because these are very poorly sorted. If these are very poorly sorted, they will form? They will form by the energetic mountain streams or result from the strong wave activity. So these are the conglomerate. So this is an example of the conglomerate, as you can see. So here, what is breccia? Breccia, if the large particles are angular, rather than rounded, the rock is called breccia. So if you look at this here, so this is an example of the breccia. So breccia has angular size particles, but in conglomerate, what is the particle? Rounded gravel size particle. So you will find the rounded gravel size particles. I hope आपको ये वीडियो पसंद आया होगा. This is a sedimentary rock part 1, but in this sedimentary rock part 2 we will cover more analytical portion, and also we will discuss the chemical sedimentary rocks and other types of the organic chemical जो sedimentary rocks हमको discuss करेंगे. I hope you like this video, and please share and subscribe our YouTube channel IS Conclave. Thank you guys.